Hi, welcome to Iteration Formula 2. Here we're looking at a few more things to do with iteration and also the main style for most exam style questions. So key thing covered here is basically how to show there's a solution between 2 points. So typically you're given some sort of an equation and you'll then be told without a graph, show that there is a solution between 6 and 7. Okay. From a graph, this is quite obvious. We can see that 7 is going to be here. So obviously there's a solution between them, and it's roughly going to be at 6.4. We're going to see mathematically how we can show that. What we're going to do, we're just going to plug in x equals 6 into this equation, and also x equals 7. So if I plug in x equals 6, I can work out the y value. So let's do that now. Okay, I've typed it in. Again, remember, it's always good practice when we see an x just to chuck it in brackets for a couple of reasons. A, it makes it the calculation of minuses come out correctly, and B, when I change x to another number, it's really easy to see what numbers I have to change. So plugging this in, I get minus 17 over 5. Let's write that down. Okay, I want a solution between 6 and 7. So now I'm also going to plug in x equals 7. So everywhere I've got an x, which is number in brackets, I'm going to replace that with a 7. Okay, that gives me 53 over 10. And this makes sense looking at the graph. We can see that when x is 6, I was negative, and when x is 7, I'm going to be positive somewhere up here. And in fact, that's enough to show that there is a solution between 6 and 7. If it was an exam, you would need to say some sort of sentence. The key thing here is you'd have to say is because there is a change of sign, then there must be a solution between 6 and 7. And the key thing you were looking for is this change of sign here. Okay? Again, for example, this will be a 2-mark question. There'll be 1 mark to do this bit of maths down here, and then 1 mark for your conclusion. Noting there's been a change of sign, so therefore it means there is a solution. Okay, let's try the same idea again, just this time without the graph to look at. So we have some equation. We're going to plug in x equals 2. Plugging that into here, we have 2 squared plus 2 times 2 minus 10. That's for easy to work out. That is just going to be 4 plus 4 minus 10, which is minus 2. I then did the exact same thing as x equals 3. So now we have 3 squared plus 2 times 3 minus 10. That's going to be 9 plus 6 minus 10, which is 5. And then we write down that same solution, sorry, that same sentence as before. Because there is a change of sign, there must be a solution between 2 and 3. That's all you need to do. It's almost just deceptively simple, so in case people do get it wrong by just sort of overthinking it possibly. So try it one more time, different notation here. So just show that has a root between 2 and 3. Root means the exact same thing. There's a solution for it equal to 0. To do this, we're going to work out f of 3 and f of 4, just using a bit of function notation. So we plug in 3 and we plug in 4. Let me get my calculator back and type this in. Okay, when x is 3, we've got minus 12 here. And replacing this 3 for a 4. We get 21. And then the exact same things for 4. We've done the hard work. We just need to say because there's a change of sign, there is a solution between 3 and 4. So really simple, not too much to do. Just make sure you follow those steps and also say something along these lines. Okay, next to do with these questions is often has to do a lot of rearranging. So I'll give a few rearranging tips. So here we have some equation. We want to show it's possible to rearrange it into this form, and we need to work out what this A is going to be. For these questions, I always recommend you basically work backwards. That is, you start from the answer and we try and make it look more nice and more normal, and basically more like this. So starting from here, the key to notice I always say is the first you want to get rid of is any fractions. We have this big fraction here, which means we've divided it by x squared plus a. So from here, let's times it by x squared plus a. And let's expand that out as well. So now we've got x cubed plus ax equals 5. Okay, that looks a bit nicer. Let's compare it to what we started with. So we started with this. Let's put them side by side just so it's a bit easier to see how they're going to compare together. Okay, we see pretty much done. If I take this 5 across, it'll become a minus. So I can rearrange to this. And you can see that this is going to be a equals 2 here. If this was an exam, you almost want to sort of then work from here to get the same answer. So then do the same tricks we've done just in reverse. So here you would then take the 5 across, factorize our x, and then divide by x plus 2. It's the exact same steps, just to make it look more nice and basically more easier for the examiner to mark and give you full marks. But the way you worked it out, I always recommend is always work backwards, because it's so much easier to see what you need to do. Let's try that same idea again. So here we start with our fairly nice looking equation, and we need to rearrange it to something quite messy. Again, we're going to use this in a bit to give us our iteration formula. For the time being, we're just rearranging it. So looking at this, same as before, we have a fraction that we don't like. So we need to times everything by x squared. Note that will include this a. So when you times by x squared, you times by every term, which means everything either separates by an equal sign or a plus or a minus sign. So times in everything by x squared. I've now got x cubed on the right hand side. This divided by x squared and times by x squared cancel out. So I just have a 5. And then it's going to be plus ax squared. Let's compare that to here again. Let's see how close we are. Okay, we see we've got roughly the same idea, but here this equals 0. So I'm going to take these two terms across to the left hand side. And again, when it does that, they are both going to change signs. Okay, now we have it in the exact same form. And we can see that minus a must equal 2. So if minus a equals 2, that just means a equals minus 2. And again, in exam, I would then basically almost redo it, making this look like this by basically going through the steps I just did here in reverse. Okay, I'm just going to finish up by looking at two sort of exam style questions based on all the steps you expect us to do. So part A is showing the solution between 2 points. So here you plug in x equals 2 and x equals 3. Plug in x equals 2 into here, we're going to get 4 plus 10 minus 15, which is minus 1. Plug in x equals 3, we're going to get 9 plus 15 minus 15, which is 9. You will then say there's been a change of sign. So solution between 2 and 3. Next, with the rearranging part. So again, same trick, sort of working backwards. We can see here, if I have a massive square root, I must have squared everything. So the previous step to this would have been this. We can then see if I take all this stuff to the left hand side, I then have this equation. So let's do that. Let's pretend we haven't done that. So this exam, we want to sort of show you doing it nicely. First step, get the x squared by itself. So that gives me minus 5x plus 15. So both change signs. Note here, they've just written the 15 first, so we can do that as well. Then the opposite of squaring is square rooting. And then we're done. Nice easy 2 marks there. And then lastly, we want to use the iteration formula. So basically using this formula here, it's now an iteration formula. So basically that is the same as that. And we're given our first guess is 2. So let's get our calculator and let's do that. We need to do it 3 times. So first we log 2 as our answer. we're then going to copy down this right hand side, and everywhere we see xn, we're going to replace it with the answer button. Doing it 3 times, so that's once, 2, and 3 times. And that is our estimated solution of 2.29 to 3 significant figures. And again, what we've worked out there is an approximate solution to this equation here. Okay, same idea again, just going through those steps. So first, you plug in the 2 points, the 2 coordinates 1 and 2. Again, we expect 1 to be positive and 1 to be negative. Working both these out, you calculate if you want to. You plug in 1, you're going to get -4 coming out. And if you plug in x equals 2, we're going to have 8 plus 14 minus 12, which is going to be 10. Then same as before, there's been a change of sign. Therefore, solution between the 2 numbers, which in this case is 1 and 2. Next, you have to rearrange it. So in looking at the answer and working backwards a bit, we can see we must have cubed this. So if I cube everything, I get to this line here, so without the cube root. And we see that's the exact same as this, just with these 2 things on the right hand side. So going through this, first step, I'm going to get the x cubed by itself. The -12 becomes a +12, and the +7x becomes a -7x. Then the opposite of cubing is cube rooting. And then we're done. Now we have it in this right form here. Next, we now want to use this as our iteration formula. We are told that our first guess is going to be 1, and we're going to plug it in 3 times. So we preload our answer as 1, so we press 1 equals. We're then going to type in this right hand side. Everywhere I see xn, I'm going to replace that with the answer button. So -7 times answer. Doing it 3 times. So once, twice, 3 times. And our estimate of our solution is going to be 2.14 to 3 significant figures. And again, that's a solution to this original equation. Like I said, occasionally you're asked to work out, to explain what you've actually worked out. Okay, I hope that helped. Good luck, and thanks for listening.